Hello and welcome everyone to another DataPark webinar. This one's called Closing the Data Divide, Merging ERP and Process Data with Mativ. A few housekeeping notes before we get started. If you are having trouble with the audio, use the information on the left or in the GoToWebinar application to connect. You'll see down at the bottom there's a place for questions. You're welcome to type those in. We may respond to questions in chat throughout the webinar, but we'll have time at the end for being able to respond to them audioly. So we'll let you ask questions and we'll be able to get to those at the end. There's some additional resources like our community forum where this webinar will eventually be posted, and our main website if you have anything that you want to look up there. So today there's two presenters. There's me, Adam Cooper. I'm a sales engineer with DataPark, who's been with the company for quite a while, helped with project implementations, and now work with the lovely sales team. And today we have joining us from Mativ, we have John Waterman. John, do you want to do a little introduction?
Yeah, sure, Adam. Thank you. Hello, everyone. My name is John Waterman. I am an asset leader for Mativ, and my company is a customer of DataPark. Now, we initially leveraged PARCview as a historian, which was over 5 years ago. And since then, we have continued to develop the features of PARCview and continue to integrate these types of features with other functions of business, which we'll talk more about today.
Wonderful. Thanks, John. So the agenda for today's webinar is we're going to talk about data integration in general with PARCview. So we'll talk about the different data source types and possible connection types. Then we'll have John tell us specifically about what Mativ had, their pain points, what they ended up doing as a solution, how that ended up working, and what they have planned for next steps going forward. Finally, we'll end with the Q&A, where we'll try to get to some of your guys' questions. So to start, we want to talk about different ways of integrating data with PARCview. So you may have seen this slide before. This kind of outlines the typical data sources that we tend to get into the DataPark system. Typically, most sites have a data historian or at least some place where they want process data, whether it's coming from the DCS or the PLCs. And then there's some other additional information that doesn't always get included, at least initially. So we have LIMS for your lab information. We have MES for additional information about production, like recipes and things like that. We have the ERP, which typically has production scheduling and some other things that we'll talk about. That'll be kind of the main focus of what Mativ has done. We have shift logs for being able to get that vital information from your operators and their day-to-day work into the system. And then there's often some other sources. It might be a specific counting system outside of the ERP, or just something that's a little bit outside of the normal scope. But we attempt to get all of that into the DataPark system so that you can see all your data in one spot. So like I mentioned, a LIMS system contains very important laboratory information. Lab data often has to do with quality testing of the final product, or just measurements that you can't get with an inline meter, something that might take time or a specific lab test in order to do. Being able to get this lab data into a system with your process data, and then also being able to line it up with the time-wise so that you can see the lab results, how they actually correspond to what your production was, is really important. So we have a few examples of different systems out there that you might be using for your LIMS, and we're able to integrate with many of them. So next is a MES, or a manufacturing execution system. MESs usually contain a lot of useful information about the raw materials that are used, the genealogy of a production lot or a batch as it travels through the process. Depending on your process at your facility, you may end up dividing up a lot as you're going through. Things may be combined later on. So being able to kind of put all of that together and track, from very beginning to very end, and see how, something upstream might have affected the results or quality of something downstream is really helpful. We have a few examples there of MES systems that you may or may not have at your site. Next is the ERP. So ERP stands for Enterprise Management Software, if you're unfamiliar. ERP systems also have useful information, things like scheduling, so knowing what you're going to produce next or within the next week so that you can kind of line up what you're planning to produce. It also has product recipes or BOM, so that you know exactly how you're supposed to be making something, or at least how it's outlined over time. That often can include important limits that might come from the recipes as well. And then finally, pricing information. Depending on your site, you may want to know in real time the costs of what you're producing to be able to minimize production costs while still making the quality product that your customers expect. So there's a lot of really useful information in the ERP system, and John will definitely explain a little bit more about how that's helped Mativ. Next data type that's very useful is shift logs. So shift logs are going to be the day-to-day records that your operators, possibly engineers, and others put in. Previous times that would have possibly been on paper. That eventually shift to other loggers like Excel. And then nowadays, companies typically have some sort of program to be able to log that. So we have a few examples here on the slide. Being able to have the shift data is really useful for root cause analysis. Having people's thoughts that day of what happened, things that may not seem important in the moment might make sense later on. A loose nut or something going on where the machine sounds funny may end up being the cause, or at least help diagnose something later on in the future. So how do we get that data into the system? There's a few different ways that you can do it, at least with DataPark. The main thing that we find people use is going to be our SQL tag template. So this is a way of getting data from another database. It doesn't have to be SQL or Microsoft SQL. It can be Oracle. It can be anything that's able to make a ODBC connection. But either being able to access that server directly or having a linked server within SQL so that we're able to access it through our own SQL database allows you to bring in the data to DataPark, but without having to double store it. So we're able to read it directly where it is. For any data that's not in a database, we have a few different methods. Typically, this is going to be done with a Park task workflow, which is usually parsing like a text file or a CSV file. It's able to take the data in that file and either save it to a historian, ours or possibly a third-party one, or save it into another table inside of the SQL database, and then we'd create a tag template to look at that data directly. So there's a couple different ways of putting it into the system. The benefits of data integration is, I think, very big and key. One, it's going to streamline your troubleshooting and your analysis. By having all of your data in one place, you don't have to look in different places. You don't have to check different applications or possibly with other people and have to wait for them to get back to you. It allows you to make well-informed decisions across departments. All of the departments are able to look at the same source of data, have the same source of truth, and then come to conclusions together about possibly what happened and how you could fix it going forward. And finally, it just eliminates redundant processes. You possibly are logging the data in two different places, or needing to get the data from a shift log or some other source and then entering it into an Excel sheet or somewhere else. If you have it all in one place, you can then pull it out into Excel or another application at once and get to the actual act of troubleshooting and spend less time actually getting your data. The other main benefit is it reduces errors. By having a system that's automatically aligning your data time-wise and production-wise, you don't have to worry about the human factor of manually aligning data and possibly making a mistake or not necessarily putting it in the right place. And also moving data from one place to another, depending on the process, that could affect the data integrity. So by already having it in one place that's embedded, you're able to pull it all together. So you can see our image down here at the bottom of the slide. We've got our different data sources that we've talked about at the bottom. You put that through the Data Park platform, any transformations you might need, calculations, aggregates, roll-ups for different time periods or production periods. And that enables you to get to the great functionality above that. Our lovely trending, notifications and incidents, our dashboards and graphics, control charting with limits in the SPC, SQC, and then finally getting reports that can be used daily or on another period basis and can help management kind of get a view of what's going on and know where to look when there are problems and not have to look when there aren't. All right. So with that, we'll pass it off to John to talk a little bit more about how Mativ has integrated data and how that's helped them.
Yeah, thank you, Adam. So like I said, the Mativ Neenah Mill facility has been utilizing PARCview as its historian for several years now. And although we have made some major developments in how our systems communicate and how we have been providing solutions to the business, I think it's important to focus on one of the major pain points that we have resolved more recently. And that has to do with recent developments in our auto assignment of materials. So when we look at the process pain points that we have been experiencing at the Neenah Mill, we can see that there is still a lot of manual intervention with the process. So the visualization on the right just illustrates how there is still a interaction from the operator level and the engineer level to help communicate data from instruments on the floor that could be meters or sensors, and passing this information through several different platforms, eventually still needing to analyze that same data and figure out how to communicate that or make sense of it for the engineer and the operations management team. So this can be a very manual process, which could take several hours or even days when we are back flushing data manually based on inventory counts or trying to figure out how much of one material we used on any given time or any given job. So this puts a lot of strain on the management team. When we focus on continuous improvement efforts, we can get bogged down with tracing back and trying to figure out how we even got to our current state or how we got variance in different jobs. So there are many models that we can create with the Data Park Excel extension. However, regardless of the types of models that we build and the analysis that we can perform after the fact, there is still the pain point of not having accurate assignment of materials across all platforms of the business immediately. So this is where we wanted to tackle this issue that we were encountering on a daily basis and make sure this didn't become a recurring discussion point for the entire team on a daily basis. The organization did consider several alternatives when we were proposing solutions to further developing our information systems. The fact that we did have PARCview at the Neenah Mill already helped us establish a baseline on what we were capable of doing. And when we consider data visualization and other improvement efforts when it comes to keeping up with current technology or even Industry 4.0 trends, there are several criteria that we need to consider in the abilities of different software and different platforms. So the pain points that I mentioned earlier, the cost of a system and how compatible that system might be with existing platforms of the business are all major drivers in the decision that Mativ made to move forward with PARCview and update to the latest version. Now, other softwares researched, for example, QIsoft, BrainCube, the Pi workbook system, and RapidMiner, all had their own individual benefits. However, with PARCview already showing the momentum to tackle these pain points and other criteria, we knew it was the right decision to move forward with PARCview and focus on the compatibility that PARCview has with our existing systems to tackle these pain points. Now, from there, we have recently gotten approval and are working on getting PARCview as the mill historian for a second facility, and we'll be expanding the synergies between facilities and other multi-facility solutions from there. The most significant use case that we have been able to tackle more recently at the Neenah Mill has been that pain point of not knowing exactly which materials were used at any given time or on any given job that runs on our machine lines. So this pain point helped make sense of the dozens of raw materials that could go into the process and be consumed at the facility level on a daily basis. So since we have been able to put more of a focus on the automatic assignment of raw materials, we now have over 55 of these ingredients or these raw materials of the process that once were manually assigned within the business's ERP system that are now able to be automatically assigned immediately. And that's upon job completion, so that we have a clear picture of what was consumed and the variance to our standards in the moment. So that pain point of waiting several days to correct the raw material data based on inventory levels or based on what we think should have been consumed on a job can lead to a lot of confusion and a lot of repeated discussions just trying to align on what the right amount of material is to assign on any given job. So the solution was to integrate PARCview with the ERP of the business. And that way we're able to bridge the gap of PARCview having all of the process and quality data and knowing what was consumed at any given time with our ERP system that has those job numbers and it has those raw material numbers, components that are actually consumed and pushed throughout the business for procurement needs and other support functions of the business. So the major tool used, of course, was the ERP system, and working with our IT network team and the Data Park team to help bridge the gap between these platforms. The end goal was to utilize PARCview and the complex SQL calculations that PARCview can perform on their end and not bog down our current systems like our ERP system that may be compromised with such a heavy backload of calculations taking place any given moment. So being able to leverage PARCview's abilities and capacity to perform these calculations was the major driver in coming up with a simple end value that can be pushed to the Oracle side with ease. The illustration here helps show how we were able to break down every step of the auto assignment process. So in the top left, we see in the yellow, every time that value drops to 0 or has a flat line is considered a trigger. And that means there's either a sheet break on the machine or we swung up a jumbo reel and we're moving on to the next reel of product. Now, we know there's a certain time frame for each of these events, or there is a trigger that would have caused that auto assignment to take place. Now, in the top right is a handful of raw materials that are accumulating or flowing into the process at any given moment. So that's information that's coming straight from the field. It's tags of data that are coming from a flow sensor, and we're utilizing the production rate of the machine at these moments to show the pounds per ton flow into the process, or at least what we were consuming at that moment. Now, a lot of the instruments and the DCS info is not in the right units that our ERP system recognizes them in. So the bottom left trend is the unit conversion and filtering of data, where if there's a sheet break at any moment, there could be a disruption in flow that we need to account for. And the Data Park team helped build that logic and build those rules so that we are matching what physically went into the process at any given moment, and that or our ERP system can easily read that data and push it to the job automatically without issue. Now, the end goal in the bottom right is the actual values that were pushed to the ERP system automatically. And we can see that there are step changes and that align with every event that took place on the machine. So every step change is a real swing up or that sheet break event where we are able to see what value was pushed for each material and what job it coincides with based on the timestamp of the event and the job information from the ERP system. So now that we have ran through several iterations of the automatic assignment, we have mitigated the manual work that takes place in trying to manually assign these raw materials to a job. Now, each raw material has that flow reading coming from the field, and some complex calculations and SQL scripts are running in the PARCview side, and they are matching what our ERP recognizes them in when it comes to unit conversions and ID numbers for these raw materials. We're able to track these totalized values that are assigned to each jumbo reel off of the machine, and this helps relieve the bottlenecks of the ERP system because our ERP does not need to perform these complex calculations, and we're able to leverage PARCview's capacity to perform these scripts. The reduced time from 1 to 3 days now to 1 to 3 hours with auto assignment of raw materials has been a major help for the operations team to get an accurate idea of how we ran the job prior, or even a day's summary prior, and make informed decisions of where we need to shift our focus for the day. We have reduced the labor to perform these manual material assignments based on inventory counts. So eventually, when we become more comfortable with this auto assignment process, we'll be able to eliminate the manual assignment of these raw materials and focus our abilities elsewhere, such as continuous improvement of the process.
So as I kind of mentioned earlier, for Mativ, we created a SQL tag template to connect to the ERP data. So what that means technically is that we set up a SQL connection between the data park database, CTC config, and the ERP data. Once we had that connection in place and CTC config was able to connect and query ERP data, then we wrote some scripts inside of the SQL tag template editor, which is part of the system config menu, if any of you are curious. When you create a SQL tag template, you'll see that there's a template name, and then basically you would set up a series of queries or scripts to pull back specific data sets based off of different uses of that data. So you can see here in the list here, we need a tag list. Basically, this is what will populate tag browser with things like tag name, the description, units, plot, min, and max. And then also description of the tags or tag info. So this is those parameters I talked about before, but could also include things like possibly the draw or interpolation mode, the difference between linear interpolation or state, being able to draw the data as you would expect it. Then we typically have a current value query. This populates the upper right-hand corner of the trend grid. So it's basically, what is the value of this tag right now, or the most recent value. Next is the data query. And this basically just says, for a given start time and end time, can you give me all the tag points between the two? So this is obviously very useful for a trend or other displays where it starts and ends at a specific time and you want to populate with data from your tag or tags. And then the last one in the list is past data. So in order to draw the trend the way you would expect it, you often need 1 point before the time span so that you're able to have the line go into the past, representing the point that it would connect with. So this is just to make sure your data doesn't look disconnected, and kind of gives you a good through line if you do end up going into the past for your data. Once you have all these queries written, or someone from potentially the data part group helps you write these queries or scripts, we would save them all together, do some testing, and then you as the end user would just see a new source and tag browser. The tags work the same. You can drag and drop them into displays. You can use them in Excel or other areas. It's just what's going on underneath is, instead of reading from the historian, it's reading from the ERP data database. So then the next step that we did at Mativ was we historized using our CTC Calc tag engine. And so we set up code so that for each raw material, we were calculating and historizing the accumulation. We were doing the unit conversion, like John mentioned, so that we could get it into the right units for the ERP system, so that it was, speaking the same language, talking like for like. And then some of the benefits about the CTC Calcs is it's VB6. It's a very accessible language. It's very similar to VBA if you've done any macro programming inside of like Excel or maybe Outlook. And then the other main benefit was that this calculation engine historizes the results. So it doesn't have to perform the calculations every time you try to access the data, where an ad hoc calc engine would have to have that additional load. So this means that John and the others at Mativ can get the results that they want very quickly. Don't have to worry about calculations because they've already been done in real time. And then they're able to take that data and put it into displays and utilize in other use cases like we've talked about. So speaking of which, we'll have John talk a little bit about how they set up the Centerline.
Yeah, thank you, Adam. So the Centerline dashboard that Mativ has been using is a great development for the operator level and the management level. It's an illustration of where we stand in terms of historical production and historical performance, as well as where we can improve. So one glance at the illustration to the right provides flow rates of some key chemicals and production rates of products that we may run commonly or maybe only once a year, but the Centerline helps to give a comprehensive look of what information is coming from the floor. Now, the Centerlines can be tailored to different positions, so we can have a supervisor Centerline with more high-level info and utilize the limits and action levels to give the operators a window or a range of operating parameters for different types of products. And we can utilize the best historical performance as kind of the starting point for these types of grades and products when we get onto them next. The Centerline that's utilized in the stock prep area could look very different from the Centerline utilized as a back tender, where in the first case, we're focused more on the colorants and brightening additives that are flowing on certain products, whereas the back tenders are focused more on their stack pressures and drying energy. In both cases, all of the information is coming from instruments in the field, and we're able to compile all of that information from different physical locations all into one screen or one Centerline that helps different functions perform their role. And one benefit of the job accumulations or the auto assignment of raw materials to the ERP system is that we're able to combine this instrument data on when they actively were produced on the floor. So Adam helped touch on these details of performing these complex calculations in the SQL Server and achieving a simple data value that's being pushed to the ERP. Now we continue to work with the Data Park team and our internal network team to connect these platforms and expand what we can perform within DataPark to simplify the support functions of the business. A couple of the items that we continue to work on with our data visualization teams is gap tracking or providing real-time cost models. So now that we do have a glimpse of what is flowing or what our machine lines are producing at any given moment, the intent is to assign costs to each of the raw materials within PARCview. And not only are we then able to see the flow rate and accumulation on a job by job level or even real-time data of this information, but we're able to assign costs of this data. So the end goal would to be having center lines of the chemical consumption given the pounds per ton flow or other common data that we're used to on the machine, but also have a next level of analysis of providing the cost per ton or other cost models of these raw materials that are flowing at any given moment. Moving on to the historical performance abilities within PARCview is that once a model is set up or a certain script has been performed or built by the PARCview team, we're able to backfill historical data. So the auto assignment that was only established earlier this year is able to go back to when PARCview was implemented as a historian 5 years ago. And that not only has helped set up a solid baseline of how we're operating today, but we were also able to leverage historical data to become more comfortable with the values that were being accumulated and assigned to the ERP. And this goes for any other model that is built within PARCview, is you're able to backfill that information or the readings to all historical data and not worry about any major gaps or major starting points with a certain project when you know that that information can be backfilled for all your historical data. So again, the results that we're demonstrating at the Neenah mill have helped to drive alignment to get PARCview's latest version at a second facility within the Mativ business. And this has helped pave the way for DataPark solutions on an enterprise level, where we will be performing the same types of developments and action items at a second facility now, but at a streamlined rate now that we have the logic in place and the scripts already built to match our current systems.
Alrighty, thank you, John. Now, we'll take a look at the audience questions, and feel free to ask any others that you have. If you could, one of the questions we had was, how long was the process to set up the SQL tag templates, get the tags historized, and create the center line?
Yeah, sure. We at this facility had worked with the PARCview team through several development items, just kind of using up our support hours that were already part of our support contract. So the PARCview team was already familiar with our databases, how our grade structure looks, and what types of triggers may be helpful to trigger these types of events for auto assigning materials. And so I think that helped kind of streamline the upgrade. So it was about a month-long process of weekly updates just to get a comfortable script in place. And that we started with 5 very common raw materials that were running at all times so that we could get a larger window of data and compare that to what our ERP system thought should have been used. And once that month-long window was confirmed to be accurate, then it was working with our IT and network teams internally to kind of bridge that gap, or basically open some firewalls, improve the access between platforms. So depending on the internal resources, that was about another month to get locked in. And we had been auto assigning in a test environment for several weeks before we finally made the call to swap the auto assignment to our actual production databases. So we gave it 2 to 3 weeks of kind of that testing with live data and live auto assignment. So all in all, about a 2.5 month process. And that's when we actually did start having values from the idea of building these scripts to having them pushed automatically to our production environment in the ERP. We did discover several other kind of logics or arguments to put in place during that test period. So maybe if we had waited 4 weeks instead of 2 weeks to push to the actual production database, we would have had a more seamless transition, but it was quick fixes with the data park team to make a couple arguments like the minimum and maximum values that could be placed in case there was like a certain type of process subset. But there's a lot we ran into kind of on the fly that are easy corrections within the production database and easy corrections for the PARCview team to make on their SQL Server side.
Okay. I see we have another question. Do you guys have any scanning system to know when a new role is brought in to the line in order to track the lot code of a certain material used at a certain time?
Yeah, on the paper machine itself, each reel or lot would be considered like a jumbo reel. And when we did bridge the gap between our ERP and the PARCview historian, we were able to get those jumbo IDs fed from the ERP straight into PARCview. So we had two-way communications between these platforms. So not only was PARCview automatically pushing totalized values to the ERP, but the ERP was then able to send run numbers and jumbo IDs to PARCview so that we could overlay this info with the process data. And when it comes to further down the line or down the supply chain, such as going into from parent to child lots and running on the next asset, that would require a bit more extensive look at the ERP and a separate set of tables or databases that are tracking those finished goods. But this auto assignment process with the raw materials in that base sheet of paper was the initial goal or within scope of this project.
Okay, fantastic. Looks like we have one more question here for me. When creating a SQL tag template, how long does it take to backfill the data? So a SQL tag template actually reads the data where it exists at the SQL database or another database. So there's no actual need for a backfill. We're able to, using the data query between a start time and an end time, pull back the data that we need as a display or a report asks for it. So yeah, in that case, there's really no need for backfill because we're reading the data where it exists. We're not trying to store it again or transport it somewhere else. Okay, I think we got one more question here. Can alarms be generated off of SQL tags? So the answer to that is yes. You can create alarms and alarm events off of tags coming from SQL. That's where having that current query for being able to read the current value is really useful for our alarm server to be able to process the alarms, as well as making sure that all of the other data is there. But yeah, as new data comes in and that information gets passed to alarm server, it will either trigger the alarm or not based off of your alarm conditions. But yeah, SQL tags, just like other tags, can have alarms off of them. All right. I don't see any other questions in the chat. So we want to thank everyone for attending the webinar. There's our website and our community forum if you have any further questions. A recording of this webinar will be made available soon. Yeah, thank you everyone for your time, and we'll catch you on the next one.